the hook. YouTube says I have 15 to 30 seconds to hook you so that you'll watch my entire video. Well, I hope I don't disappoint. I don't have a hook. And the video's kind of long. But if you're into buses and you're maybe designing your own electrical system, or you just want to know what's possible, and you just want to get an idea of circuit logic and DC to DC chargers and battery chargers and AC circuits and DC circuits and how they all work together, then this video might be entertaining and interesting to you to see what I've come up with. And this is just the first version 1, sorting out the logic, sorting out what I want to get out of my bus electrical system, how much power do I need, and figuring all that stuff out by doing. So without further ado, let's jump into it. There are 2 distinct power systems in the bus Sunday. The 120 volt system and the 12 volt system. Right now, the bus is just idling along and the lights are on there, but the television's on. All the network is up and running. Everything's in standby. The bus is completely active. The computers are on. Sound system is on. Everything is on. We're running 442 watts, 4.2 amps. So let's see here. I think these are using a lot of power. So yeah, we're running 390. Yeah, so 3.6 amps. That's the number I see. So 3.6 amps at 122 volts is the working load. That's the basic, how much power it takes to run the refrigerator, this refrigerator. This is also a 12 volt refrigerator, but it's on 110 right now. It automatically switches to 12 volt when 110 is not available. So everything's on, and it only requires 3.6 amps to run my bus. 51% humidity, 75 degrees. And this heat pump is on, but it's not doing anything because everything is lovely. There are 2 distinct power systems in the bus. A 120 volt system and a 12 volt system. So this device here manages the 110 volt, and you can see that there's 122 on the main coming into the bus, but there's nothing over here. I'll go ahead and turn on the inverter, and we'll see the voltage show up here pretty soon. There it is. So 112 volts on the inverter. So it's got two options for 120 volt service. So if I turn off the 30 amp service that's in the plug on the side of the bus, it'll just automatically switch over to the inverter side. On the 12 volt side, there's a similar device right there. And you can see it says 13 volts. And it has this is what's powering the 12 volt panel up there. And it has 2 power sources. It has a lithium battery power source, and it has a 110 volt, 55 amp AC to DC power supply. It's configurable in many different ways. Most RVs come with these. They're often used as chargers as well, but at the end of the day, you don't want to be using your 12 volt batteries 24/7 when you have AC power available. You want to use a power supply that supplies 12 volts from the AC side to your system. And then when the AC disappears, this instantaneously switches over to the battery. There's one more charger we need to talk about, and that's this DC to DC charger here. This is a 40 amp lithium programmable DC to DC charger, and it allows the bus to take over charging the lithium batteries. So when the bus is running, it can charge my batteries. And the goal there is, if you're traveling along, your 12 volt refrigerator, your 110 volt refrigerator can continue to run. All of your systems can stay alive. It's like you never left your plug, right? It's like you never unplugged. So having the DC to DC charger allows me to make more than enough power to support the 3-4 amps, the 300-400 watts that this bus consumes AC, while it's just kind of in a static configuration. In other words, it's not making heat or cooling. Other than that, it's right in that area. So again, we have the 120 volt system, and we have the 12 volt system. The 120 volt system has two mains. It has the 30 amp service that comes into the side of the bus through the power cord, and it has the inverter main. So either one of those can supply the 120 volts. The 12 volt side has two mains as well. It has the lithium battery main, which can supply 12 volts, or it has the power supply that's 110 volt power supply that converts to 13 volts and supplies it. So it has the power supply or the lithium battery. So as you can see, we've got 0 voltage here because the inverter's off, and we have 122 on the main coming in the plug, the 30 amp plug. So what happens if we, what happens if we turn off the 120 amp main and all the computers, everything is still on, the whole bus is active. It's running almost 500 watts, 4.65 amps. The lights are on. That's why it's a little bit more than normal. So what happens when I turn that off? Well, we lost a few lights, but the computers are still on. The sound system's still on. All of the scene lights are still on. All of the modems, the clocks, the sound system, the television, everything's still on, but we have no AC power. And we have no inverter on. We have no AC coming into the bus, yet all of these AC powered devices are still running. I could be driving along right now, and all this stuff would be up and running, and you have to ask yourself, how the heck is that? APC UPS, uninterrupted power supply. APC is the brand, uninterrupted power supply. A lot of people sell them. They are computer and 120 volt battery backups for devices, whatever you want to use it for. So there are two of these APC UPSs on board. One handles this entire media station, and the other handles this entire media station. So it simply doesn't matter if the bus is hooked up to 110 power or 12 volt or anything, because those UPSs will continue to provide power for about an hour. So the reason that's great is when you have a bus and you actually use your bus and you drive it and take it places, you want to have some time. So for example, I'm going to disconnect my bus from the 30 amp service, and I'm going to maybe switch it over to the inverter, or maybe I just going to be disconnected for a few minutes. I don't have to worry about all my systems going offline, turning off computers, turning off all my media stuff so it doesn't get a power shock. It all just going to stay live. And I know that it's only going to stay live for 45 minutes to an hour before it runs out of battery power. But in that time, I can either get it onto the inverter, or I can plug it back in, or do whatever I need to do. But it gives me that time cushion. The second reason is you want to protect, in an environment like this, you really want to protect all your sensitive electronics. You don't want them exposed directly to your power system, even when it's done great like this. You just want the stable, good juice going to those components, so you don't wreck your, all your expensive stuff. So there's the reason for that. Let's go outside and check out the electrical box for the bus, and where I'm going to be putting the second battery solenoid this evening. Look at how beautiful that is, which is gorgeous. So here's the one fuse, solid state resettable fuse for the DC to DC power system in the bus, taking its power from one of the main power buses here. I'm going to be installing a second battery isolation disconnect switch here, because as it is right now, I have to start the bus and then come out here after everything's settled, come out here and then turn on DC to DC charging. And I would rather just use a switch like the one next to my main disconnect switch for down there. So anyway, there's a peek inside the electrical cabinet. Looks cherry, doesn't it? Well, that's how it should look. This is the Blue Sea system for my DC to DC charging, so that I can have AC power when I'm running down the road and don't have empty batteries when I arrive at my destination. I'm so excited. This is just so awesome. Okay, there it is. The Blue Sea's ML solenoid tied into the bus bar there for the bus, with the circuit protection there, circuit breaker. And then an additional switch in the dash to turn that on and off. So this is for the DC to DC charge controller. The ML solenoid, Blue Seas, allows me to remotely disconnect and connect it to the main positive bus bar there. There's a circuit breaker. Look at the gorgeous, look at how beautiful this all is. Just incredible. Like brand new. One of the most critical things for me was that I had a working amp gauge on the bus, and I was so excited when this bus actually came with this super high quality, expensive amp gauge, 300 amps discharge and charge, but it didn't work. And for me to be able to allow the bus to power the AC systems, I needed to have a sense of what draw was that on the system and how was it managing it. So I really wanted to be able to have an eyeball on that usage. So believe it or not, it took me almost the entire time I've had this bus, almost 2 years, to come to find out how it worked. There's just no documentation in the service manual. I have all the documentation, and this was an aftermarket add-on. After the bus was sold, the bus company installed these parts. So I had to really figure out, how it was worked. Turns out it was a bad sensor. Yep, all it was a bad sensor. So there, I bought two. I have this in my spare. And so this allows me to monitor the amperage, current, discharge or charge rate of the bus. All right, so over here's the new switch. So if you've seen my previous videos, you'll know that this one here is the battery disconnect for the main start batteries. And now this one here is the battery disconnect for the DC to DC charging system. So let's say you're driving along, or you don't want this on all the time. You don't want your DC to DC charger to just turn on, whenever it feels like it. You want to be in control of that. And so I certainly don't want it on in the startup phase. And I want, everything to get up and running, get things warmed up, get things going before I engage the DC to DC charging system. So there's the new switch. Okay, let's put it all together. Let's turn everything on, and I'll show you the amp gauge. I'll show you the switches in action. We'll put it all together. So we'll take the bus off of the 130 amp power plug. We'll get it onto the inverter. We'll get the bus fired up, and we'll engage the DC to DC charger, and we'll see how that how all that works. Okay, I'll power on the inverter. I will go ahead and turn off the mains. It's going to switch over to the inverter here. All the lights should come back on. There it is. Okay, so now we're on the inverter. Oh, and the lithium charger started up. So we're going to turn that off. Siri, house charger off. Oh, I may have screwed up that command because I've been rewriting them. Siri, house charger off. She might not have understood me. Yeah, there she goes. She turned it off. So we can't have the house charger on charging the lithium battery. We want it completely on the battery itself. We are consuming 300, 400 watts, and everything is rock and rolling right along. We're on our 1000 watt pure sine wave inverter running on a 100 amp hour lithium battery, and we have approximately 3.5, 4 hours that we can go on that one battery in this configuration, in this state right now. So let's go ahead and again, nothing changed. Everything is just like it was. All right, let's fire this thing up. Okay, boom. So the key doesn't do anything. All right, so we'll come over here and we'll connect the main batteries. All right, now things are coming alive. We'll go ahead and turn the ignition on to the on position. I think she's already got air, obviously. This thing just holds air like you won't believe. All right, the glow plugs are warming up. And it looks like we're pretty good there, so we'll go ahead and fire it up. We have 12.4 volts. And scan gauge firing up. And all right, oh, and we're pulling, it's charging 25-30 amps right now, trying to make up the battery start, and we're on 14 volts, and it's going down slowly. Go ahead and turn up the idle a little bit. Okay, everything is stabilizing. Air compressor just turned off. Turn on the backup. Okay, DC to DC charger. Oh, there it goes. And no big difference there. Everything's golden. I tell you, I'm gonna want to get rid of this 1,000 watt pure sine wave inverter. The fan is loud, but it's all just an experiment. All right, look at that. DC to DC charger is charging. We have 13.2 volts at the lithium battery, fully charged, 329 watts. The bus is completely self-sufficient, all on its own. Everything is running on its own, no cord attached. Everything's alive, all on a 100 amp hour battery with nothing being stressed. Everything is completely relaxed. Look at that, the bus is doing that. Is that just fantastic? Pulling 11 amps off of the, what to think about that. It's 28, so that's the DC to DC charger, putting 28 amps in off of the bus. Wow, how cool is this, guys? How cool is this? Oh my gosh, this thing runs so good. Look at that. Look at that. Just amazing, guys. Anyway, I was so excited to show this to you. So this is all just, once I get the solar in, a lot of this will go away, but this is all about building the logic circuits, building the understanding of how I want to do this, how I want it to work. Obviously, I'm going to have at least 5 kilowatts of power at 48 volts, not 12. So there's going to be some minor changes, but this configuration is how it's going to work. This is how the bus is going to work. It's just going to get more powerful, that's all. I wanted to give you one more visual of the DC to DC charger effects on the bus. So I'm going to go ahead and turn the battery bank, the main house battery bank, start battery bank on. Okay, that allows me access to the house bank. And I'm going to show you this while I'm turning the house bank, the DC to DC charger on. So the key is off, the bus is off. Right now there's currently a break even on the battery. We're at 13.1 volts. I'm going to turn the DC to DC charger on. The lithium battery, onboard lithium battery, is partially discharged. Okay, so the DC to DC charger is on. You can see that it's starting to ramp up charging on the lithium battery. Because the engine is not on, the start battery voltage is going down pretty quickly, and we're at about 40 amps, 50 amps, 49, somewhere, so right in there. So if this voltage was to get too low, it'll turn the DC to DC charger off. But this was just to show you the load on the system. This system has a 200 amp alternator, so it's nothing for it. Honestly, it's nothing. I'll turn it off now. Siri, start charger on. So Siri will turn the start charger on, and we should see the voltage go up here. Yep, there it is. It's on. I'm going to get up to 13.2 here. So there you go. There's one more visual. Now we're already at 13 volts. So we'll let that stay on for a little. She'll turn it off automatically once it's charged. So everything's off.